everyone, it's Coach Fred here, and we're going to be doing a quick review of lines and slope today. So remember in Algebra 1, we spent a lot of time looking at functions, and I'd like us to think about the 4 ways I want you to feel comfortable representing linear functions. So let's look at this equation of a line. So I know it's a function equation because it has both an input and an output. It has an x and a y. Now, this equation we can look at 4 different ways, and sometimes looking at it a different way or with a different approach can help us learn more about the function itself. So here's what I mean. We can look at things symbolically, which means an equation or a function, visually, a graph of it. Numerically, I could give it a table of values, and often I could describe it with words. All right, so let's look at this function. Symbolically, y equals 50x plus 75. That's the equation or function. So that's the function equation. So y equals 50x plus 75. Now, some of you feel completely comfortable looking at that. Now, visually, a graph of that function, I could graph it, and it's still the same function. Here I have an x, here I have a y, and I have a y-intercept of 75, so a starting point of 75, and I have a line that has a positive slope. That's a quick sketch of that graph, okay? All right, numerically, I could actually create a table of values, right? So a table of values, I could give you some points. I'm gonna, I don't know, use -2, -1, 0, 1, and 2, and I could plug those points in. So that's going to give me -100 plus 75, which is -25. -50 plus 75 is 25. 0 is 75. 1 is 125, and then that's 175. So this is a numerical representation of that function, meaning at these inputs, it gives me these outputs. Now, descriptively, we spent a lot of time last year thinking about what we could gather from that particular equation. So this might be a word, like a real-world example might be a plumber charges $75 to make a house call, for a house call, and $50 per hour, where X is number of hours, and Y is the total charge the total amount he charges. So Y is total cost. So that is a way to represent this linear function in words. But guys, these all mean and represent the same thing, but looking at them in different ways can give us different approaches to things, okay? If you get stuck with one, try to go to another. All right, more on linear functions. Last year we spent time learning about the 3 equivalent forms of a linear function. So standard form, so ax plus by equals c. Slope-intercept form, which is y equals mx plus b, or y equals b plus mx. And point-slope form, which is y minus y1 equals m times x minus x1. All right, so there's some things that we know about these equations. I know that in standard form, the easiest way to graph is by finding the intercepts. This is when we make a table of values and we let x be 0 to find the y-intercept, and we let y be 0 to find the x-intercept. It's a very quick and easy way to graph it. We also know that the slope, to find the slope, we take -a over b. All right, slope-intercept form, we know that the slope is m, and we know that the y-intercept is 0, b. And remember, we always write our intercepts as a coordinate point. Point-slope form, we know that m again is the slope. And we know that x1, y1 represents a point on the line. And all of these are going to be things that help us. And we just get to decide which one we find to be most helpful in the situation that we're given, okay? All right, so let's talk about slope, because that's, when it comes to lines, we really need to focus on that slope, that rate of change, okay? The rate at which something changes. All right, slopes can be positive. That means they rise from left to right. They can be negative. That means they fall from left to right. They can be zero. Zero slopes mean they are unchanging slope, and slopes can be undefined. Okay? All right, and then you learned last year 4 ways to get slope. You can find slope using a slope formula, which would be the change in y over change in x, or y2 minus y1 over x2 minus x1. So each of these points represents x1, y1, x2, y2, and you could subtract the points. 9 minus 2 all over 8 minus 2, so my slope would be 7 over 6. Quick, easy way. Most of you felt really comfortable finding slope. You also may be asked to find slope from a table. When you're looking at a table, remember to do change in y over change in x. So when I look at change, it's just the difference between the two. So from -3 to 0, I'm going up by 3, up by 3, up by 3, and up by 3. Oh, that's nice. And on this side, I'm going up by, let's see, 4, up by 4, up by 4, and up by 4. All right, so then my slope would be the change in y over the change in x, so 3 over 4. We could be asked to find the slope from a graph. When you want to find the slope from a graph, again, as a reminder, find index points. Don't make it any harder than that. You might pick this and this as an index point and do rise over run, or change in y. So up, it's going up 2, and it's running 1, 2, 3 to the right. So my slope would be 2 over 3. Now, what if we didn't pick those points? What if I say I picked this point and this index point? Let's see what happens. 1, 2, 3, 4, so up 4 and over 1, 2, 3, 4, 5, 6. So my slope would be 4 over 6, which in simplified form would be 2 over 3. It's important to know that if a point is on the line, you can pick any points on the line to find the slope, okay? Because they all would have to have the same slope to be on that line. All right, and then another way to consider slope is actually when we have to interpret slope from a word problem. So Bear started the day with an irrigation pipe that was 120 feet long. He used the equation L equals 120 plus 15S to determine the total length of the pipe as new sections of pipe S were welded onto the end. What's the slope of the line? Well, first of all, you have to notice it's a linear function. It is because the highest exponents are 1. So in this case, my slope would be 15, because this is in the form y equals b plus mx. So what does the slope actually mean in context of this problem? It means that for every new pipe added, sections added, the total length of the pipe increases by 15. Okay, guys, so that's it for today. Actually, you're going to watch the second video, sorry about that, on horizontal and vertical lines. But that's it on slope. Hopefully that was all review for you. Have a great day.